Hello, I'm going to show you how to detect memory leaks using Memory Validator. First, we need to launch the target application. So click the rocket icon, click Launch Native and Net Applications, browse to the application you want to launch, and here I've chosen the native example application from the examples directory that's installed with Memory Validator. Click Launch to launch the application. And you can see the attach activity happening in the top left hand corner of Memory Validator's display. Pretty soon you can see data starting to be loaded from the target application, and the application has loaded. It's already created some memory leaks, although you can't see that yet. I'm just going to create some more by displaying the about box, which happen to know leaks memory, and we'll close the target application. And pretty soon Memory Validator has calculated what has leaked. By default, Memory Validator will automatically display the memory tab when your application closes. This is to show you the leaks. If you wish to have a different tab displayed, you can change that from the settings dialog. Because of this top example, it's saying it's detected 10 objects. This is because 10 allocations have happened on this very same call stack. So rather than show you 10 items on the display, we show you one and tell you that it represents 10. So if we expand this, we can see where it happened in on app about. Expand this, you can see the in-place source editor. If you double click, you can see the source code in Memory Validator's editor. If you prefer this in your own editor or in Visual Studio, you can change that from the settings dialog. Here we can see this is a simple for next loop that allocates some memory and doesn't deallocate it, which is why it's shown up as a leak. If we go to the timeline, you can see that we've got a timeline showing memory allocations, handle allocations. So total, unfreed, memory allocations in order, deallocations in order, and deallocations in allocation order. If this was a longer running program, you'd see scroll bars here to scroll around it, but this is a short example. The displays allow you to view your application's allocation behavior. The difference in the two deallocation views allows you to detect memory deallocation behavior that may not be optimal for the job that's being performed. Sometimes you'll want to deallocate in the order you allocated, other times you'll want to deallocate in a different order, quite often the reverse order. If we move to the statistics tab, we can see we've got data types ordered, and you can order them by type or count or size or maximum value, and you choose the column head of the sort and double click again to reverse the order. Sizes shows the same information but by size instead of type, and locations shows the same information again but based on the allocating function in per DLL. Generations and ages are for .NET applications, so we can't show you them for this native example. If we move to the analysis tab on the hotspots, click refresh, and it will show you a tree of all the memory allocations in the program, and by default it opens up the most expensive branch on the tree. So here we can see we've got nearly 55% of the allocations in this application happening in one location, 123,456 bytes. We move to the coverage tab. The coverage tab shows the locations in your source code where memory and handles are allocated and deallocated. This allows you to find allocation and deallocation locations that are not being executed by your tests, allowing you to easily improve your memory and handle leak testing. So here we can see some locations that haven't been executed. If we scroll down a bit, we'll see some allocations that have been allocated. So this allows you to find out which bits of your code need some additional memory leak testing. So you need to write some tests that execute these bits of code and check they don't leak. Memory Validator, simple and easy memory leak detection. Thank you very much.